Yes, students, let me discuss the question asked by Namrata. Her question is regarding the angular shapes of the orbitals. And while discussing that angular shapes of the orbitals, I discussed the question which I asked previously, and now again Vaibhavi has brought that question up. Still, you are not getting answer about the allocation, alignment, or orientation, or distribution, or movement of electron in say p orbital. First, one by one, the angular shapes. Understand that shapes exactly what, how can we understand the alignment or existence of the electron? For that, you need to understand the first basic principle of quantum chemistry, that is what? De Broglie equation. What is de Broglie concept? De Broglie said electron, previously people were considering it as a particle. This electron is a wave. So he has given yes, I was saying to understand his angular shapes, you should understand first one principle. Will anybody help me? What was the principle?
Sir, your screen sharing is not started yet.
Thank you again. Setup since sharing is not started. Whoever has said great work done. I want such kind of enthusiasm and clarity. Good, thank you. I think it is sharing now. Could you able to see the screen now?
Yes, sir.
Yes, sir.
Good, good, thank you. Yeah. See the first principle. What is that?
Right.
Which is necessary to explain the electron? Yes. Will anybody help me?
De Broglie's principle.
Yes, it's a de Broglie. What de Broglie said, electron is a wave. It's a matter wave. And when any wave came, means one trajectory should be there. And if any trajectory is there, then we should able to explain it by means of the mathematics. And for that, a Schrodinger, great mathematician, has given his own equations to describe that wave as a wave function psi. Psi as such has no physical existence. Means if I consider here cell phone is there. Cell phone is physically where it is on the table, or the pen is there. So it has the physical existence. I could see that here writing pad is there, system is there. It has a physical existence. We could able to recognize that, we could able to understand that. But that wave function as such has no physical significance, means exactly where it is, how it is not easily cognizable. Therefore, we say wave function has no physical significance. The weight, height, color, the physical significance aspect. But when we consider wave, it has no particular wave is there. Likewise, we can't say. So therefore, we say it has no physical significance. Psi has no physical significance. But you might have heard psi square of that wave function has the physical significance, and it signifies electron density. Electron density, or more correctly, the probability of finding the electron. Electron as a cloud, as a nebula, we are understanding. Where is more electron cloud? Where that becomes less. Ultimately, where possibilities there are no electron. So within that region, more electron density to less, ultimately to zero. So within that, we could able to find the electron, and that electron remains in orbital, and that orbital is described properly by this Schrodinger. What Schrodinger said, if you solve this wave function, which is a differential equation, those who have studied little mathematics, they will understand. It is a differential equation. Simple linear equation, linear quadratic equation. is 1. Means y is equal to mx plus c. It's a simple linear equation. But x square, y square or xy such terms comes, it will be quadratic equation. But when differential terms comes, derivative comes, then it is a differential equation. And the differential equation, various operators are there. I'm not going deep in that. So that differential equation, if you solve, those who do study the mathematics, they do solve such differential equations, but not an equation of Schrodinger. At low level or at the beginning level, you are studying the differential equation or differential calculus. That differential equation after solution gives 4 terms. Actually, Schrodinger said only 3 terms. And that differential equation is with the 3 variables. As per Schrodinger, I am saying. The first variable is n. Will anybody help? What is that n?
Principal quantum number.
Right, principal quantum number. Second variable is L. Yes, please help me.
Azimuthal quantum number.
Azimuthal quantum number, and about which Namrata had asked the question. That is related to that azimuthal quantum number. And more correctly, the question of Namrata is related to the third quantum number. It is ML. It is called as
Magnetic quantum number.
right, magnetic quantum number. And one time I had a discussion about those all 4 quantum numbers. But development, I am saying to you, Schrodinger could able to describe that. But when Dirac came to know the limitation of Schrodinger, Dirac, a name of other scientist. Dirac said Schrodinger has not considered one more variable. It is needed, and that is nothing but the intrinsic quantum number. It is called as S or MS. It is a spin quantum number. So with these 4 variables, what achievement we could able to do? We could able to describe the electron. Electron exists where? In orbital. Main principal level or shell number, then sub level, and within that sub level, various orbitals may possible. Means if I consider say 2p as a sub level, 2 is a principal quantum number, p as a sub level, sub shell, and that sub shell has further 3 parts, px, py and pz. Students, could you able to understand what I am saying?
Yes,
Yes,
sir.
sir.
Yes, and we'll talk about that px, py and pz. Px, py and pz, that concept is related to magnetic quantum number. P is a concept related to azimuthal quantum number, and 2 is a concept related to principal quantum number. And in those orbitals, when electron remains, they will remain with the fourth or the intrinsic quantum number, spin quantum number. Their spins will be different. That is our MS. But one achievement we could able to do, we could able to understand the wave which was proposed, initiated, described by de Broglie. That is the importance of Schrodinger and Dirac. Third, very important development that one did, or one has given the very interesting insight for the electron, and that is by Hensberg principle. And that Hensberg said that I'm saying about the wave. So exact understanding of the wave will be there. Exact locating that electron. And by the way, finding its momentum, because electron is not static. Electron is not at one place. It is changing the place. So exact position is not possible, so error will be there in its measurement. Exact momentum is not possible, so error will be there in its measurement. So simultaneously, if we attempt to measure, to find position and momentum, then multiplication of their error will be equal to h upon 4 pi. Our Heisenberg one story is there. I share here the story. A young chap of 24 years was doing research in the laboratory of a brilliant, genius scientist, Max Planck. And one day, Max Planck was working in the laboratory, and to help him, the Heisenberg was there. But Heisenberg got bored. He was working, studying. So Heisenberg came out one desk was there, or you can say bench was there. He sat there on the bench. Sorry. And after some time, he felt that dizziness or drowsiness. So he stretched himself on that bench and he went in deep sleep. After completion of the work, when Max Planck came out of the laboratory, he saw a lab assistant in the sense what? Actually, research scholar only, taking full rest. But well, he was going out, but suddenly Max Planck found one chit. It fell from his pocket. It was down on the floor. So with curiosity, thinking it may be the love letter or anything, he took that and just he read that. He was shocked. I repeat, Heisenberg is on the bench in deep sleep, and from his pocket one chit was fall. It was on the floor, and that Max Planck has picked that and he opened it, considering that some personal matter or such things will be there. He opened and he read. He was shocked. What was written there? Simultaneously, exactly. One cannot measure the position and momentum. Okay, up to here, okay. It was also a very fantastic idea. Max Planck was very impressed by that. Next line is very important. An error in the measurement, multiplication of error in the measurement is equal to my boss. Who is boss? Max Planck. And who is reading that sheet? Max Planck. So after completion of the work, though Max Planck went to the home, but he was feeling somewhat restlessness. What exactly Heisenberg want to say? Next day when the laboratory was opened, at that time he called Heisenberg and asked what exactly you want to say. He revealed, I read that sheet and it was there. And he described that at that time h upon 2 pi or 4 pi. The still confusion was there, but afterwards it was proved that it is equal to h upon 4 pi. He wanted to say the multiplication of error is equal to the boss. That's the h. What is h? Please help me.
Planck's constant.
Planck
Yes,
constant.
it's boss Planck. So it's constant. So related to that, at the beginning he what the wrote means rough idea he what the put out. Then by electron microscope it was proved. Heisenberg was found to be the proved. But because of Heisenberg, new insight was got. Because Einstein was not in favor of the de Broglie. De Broglie's idea was because Einstein said wave can be particle. Means dual nature of wave he explained. De Broglie said dual nature of matter, opposite to Einstein. Both are correct actually. But Einstein was not in favor of that idea. But when Schrodinger put forward equation, when Heisenberg also come across that, then there is no alternative. Einstein also has to accept that because of Heisenberg, exact how the nature of that wave, how that matter wave people could able to understand. And interestingly, I prepared videos also. Why electron is outside? Why protons and neutrons are inside? Why not electron inside and proton outside? There also a possibility. If atom has to be neutral, electron can be in the nucleus and proton can be outside. But it is not. Answer for this we can give only and only after application of Hinsberg principle. Students, are you in tune with me?
Yes, sir.
Yes, sir.
Good.
Yes,
It's a
sir.
very, very interesting. Historical developments
Yes,
are very interesting. And that will give you the insight. But what exactly this Heisenberg want to say? Position and momentum. By the way, about energy and time also he said. But let us not get confused for that. What Heisenberg want to say? What de Broglie want to say? What Schrodinger want to say, or what modern quantum chemistry or quantum mechanics want to say, that I explain you by means of one story. Actually, Bhavesh Chavan sir from physics, no, he had shown me that video. Quanta Fest was there. Quanta Fest means related to quantum studies. One gathering was there. Means cultural activities, how we remain, no? Likewise. So one group has presented their drama to understand quanta, to understand quantum, to understand quantum mechanics. So what is that drama? I narrated that drama. Interesting video it is. I don't know now on YouTube it is available or not. Just search Quanta Fest. May possible you will get that video. But I narrate the story of that video. It was shown one girl is in library and she's studying. She's reading. Books are there. And while reading, suddenly her mobile bips. Means message comes to her. And it was shown there, message. And message was from whom? Message was from particle. So particle is a friend of whom? That girl. And that there is a dialogue. Means it is shown there. Message came. So she also typed up one answer. This message went. Means there's a relation between a particle and dial and that girl. Means it is a conclusion of that. Easily one can understand from that. Again, same scene. She is reading, she is studying. And after some time, that girl finds a message from other friend. That's a wave. So again, message from whom? The wave, and then dialogues, interaction. She also typed the message, so interaction was there. So it shows that girl is in that relation with particle and wave. It take it positively. Understand. For understanding purpose, I am saying this. Means there is a rapport. So it is a one incidence. Second incidence. It was shown again. Girl is at one house or the home, you can say, and she is reading the newspaper. She is on first floor. She is reading the newspaper, and one boy from outside knocks the door. And that boy was none other than particle. Means particle is knocking the door. What is our expectation? Girl is there in the house. So it is expected that girl should open the door. But suspense is there, and it is slowly is opened. The door is opened by whom? By wave. Wave was inside, Miss Wave, other boy opens the door. As soon as particle comes to know, one boy comes to know, a wave, other boy is there, and about which particle was not knowing. Particle was unaware. So as of a sudden, a particle becomes furious. Means you can say angry, disturbed. So he search that girl. So he goes to first floor. Girl is reading the newspaper, and that particle goes, and particle asks, "Why are you behaving likewise?" Students, are you understanding what I am asking? The story narration.
Yes, sir.
Yes, sir.
Yes, sir.
So particle
Yes, sir.
asks the girl, "Why are you behaving likewise? I thought that you are with good rapport with me and me only. But I realized you're with rapport with the wave also. Who are you exactly? What is your intention?" The girl simply answers. The answer is, "It's my nature." And that particle again, Miss what becomes so furious, he opens the gun, there's a revolver, it is shown revolver, and he shoots. So a sound of bullet. So as a person means what as a spectator will feel. Now particle has shooted whom? Girl. Next part is shown. Girl is climbing down, you can say, or coming down through the staircase on the ground floor. Means girl is alive. What it wants to say, when particle shooted the girl, means considering electron is there. Girl is what? Electron. When bullet was shoot, proper aim may be there, but very next moment, girl was not there. Girl was otherwhere. It's her nature. Means girls want to say, it's my nature. I have dual nature, particle as well as wave. That's not existing at one place, having an error in the position. That's the Heisenberg uncertainty principle. That's the understanding of de Broglie concept of the wave. That's a matter wave. That's the understanding of the electron. So electron doesn't remain at the one place, it moves. So there's a locality, but it localized a particular region. In that only the electron will be there. But exact location of the position we cannot not predict, or we can't not understand that. So the nature of electron wave was explained by this one drama in Quanta Fest. Is the conclusion of that drama clear to you?
Yes, sir.
Conclusion is, girl is an electron,
Sir.
Yes.
and she has dual nature. She has double nature. One is wave and other is particle. Because of that wave nature, uncertainty in the position remains. And that is our Heisenberg uncertainty principle. And because of that uncertainty, there remains a probability of the finding the electron. So I said no previously, psi has no physical significance, but psi square has. So probability of the existence of the electron gets the importance. And the probability of existence of electron is a shape. Suppose if we consider, then that shape is none other than the question of the Namrata. And her question was regarding orbital. How the electrons are oriented or allocated accordingly, orbital will be understandable. Then orbitals are also the different types. Because of what? Because of azimuthal quantum number. When student just wait, that's system battery is low. Let me start that charging. Yes, that azimuthal quantum number, when that it takes value L is equal to 0, yes, will anybody help me? Which orbital it is?
2s orbital.
No, no, no. Any s orbital. 2 is a principal quantum number or shell number. I am not now interested in the principal quantum number or shell number. I am interested in azimuthal quantum number and magnetic quantum number. When L is equal to 1, what we say?
P
Which
orbital.
sub level it is? It is P sub level. Means properly P sub level. In that Px is orbital, Py is orbital, Pz is orbital, P is a sub level. But all are equivalent. Therefore, our habit is to say P orbital. When L is equal to 2, then which orbital?
D orbital.
D orbital.
All are small, all are small. S also is small, P is small, D is small. And when L is equal to 3, then which
F.
orbital? It
F
is
sub.
F orbital. Yes, yes, it's a great F subshell. So S subshell, how many such subshells are there? Means S subshell. In that S subshell, how many further parts are there? How many magnetic quantum number now? How many orbitals are there? The answer you will find there is only one orbital. That's S. When P sublevel you consider, how many orbitals are there? 3. When you consider D, help me. How many orbitals are there?
5.
5.
Right, right. When F, how many?
7.
7.
Right. 7. So these are the orbitals. So how are those labeled? S only one. So it is considered as only S. When P, then it is considered as Px, Py, and Pz. When D, it can be considered dx square minus y square, dz square, dxy, dyz, dxz. Like as 5. F, the quadratic systems are there. F, x, y, z means in a three chord, or you can say it is not quadratic as such. The power or order of that equation will be what? The 3. X cube, z cube. In that complicated words are there, complicated nomenclature are there. So I don't want to confuse you. So up to D, you come to know these are the orbitals. So if I have to represent their shapes, say for example, S orbital, then how can I represent an S orbital? If I consider nucleus here nucleus, dark nucleus is there. And around that, by other color, I show the electrons. So dark not came. Okay, by blue color, I show now the nucleus. Here is the nucleus. And around that, by other color, I represent the electrons. So here are the electrons. Color not change. Yes, change. Here are the electrons. So at the beginning, you will find large electron density. As you go out, you will find electron density becomes low, low, and at last you will find electron ends here, up to here. So what is this? It is the orbital. It is the angular distribution, spherical shape. It is the understanding of S orbital. If I have to describe the Px, then again I have to consider the nucleus. Let me consider nucleus here. And electrons, if I have to represent, then near the nucleus, you will find more number of the electrons. Towards one side, it's for understanding purpose. And here towards other side. Actually, it's a three-dimensional aspect. More number of electrons. As you go out, the electron density will decrease. Electron density will decrease. Further, if you come out, it will further decrease. So what is this? It is what the P orbital. Let me consider this as what the x-axis. Then that is what the Px orbital. Yes, students, are you understanding what I'm saying?
Yes, sir.
My question to you was, if this is a px orbital and if electron is moving, then electron comes towards the nucleus, then from nucleus it has to come other side, no? Through nucleus. Nucleus is a positively charged, electron is a negatively charged, and if anything goes there, the nucleus will trap the electron, will swallow the electron, will grasp that electron. How can electron come out? That was the question. Yes. Can anybody answer? Vaibhavi, sorry. Other students, Vaibhavi, I think Vaibhavi has reminded me. Sorry, has reminded me that question. Anybody knows the answer for that now? Yes, will anybody attempt? Shall I give the answer?
Yes, sir.
Yeah, see, it is because of the Heisenberg uncertainty principle. There is uncertainty in finding the electron. So electron is in the cloud. Electron is moving here and there in such a way that electron is not at all here. It is absent at nucleus. Electron is not going. But our problem comes where when we consider electron in a orbital motion, means as like Earth revolves around the sun, likewise we think electron is moving from here and there. Yes, in that way, it is not fact electron is now here, the next time it will go here. No, it can go anywhere. As like the gas molecule randomly moves. Kinetic theory of gases you might have studied. So if gas molecule is here, can anyone predict where that gas molecule will move? Will towards your side, will towards me, towards my right side, towards left side, upside, downside? Where will it move? We cannot predict. Likewise, electron, if it is here, then where will that electron go? We cannot. Here it can go. It can go anywhere, randomly, anywhere it can go. But overall understanding will be it is in the form of dumbbell. That's our px orbital. It is along x-axis, therefore we are saying px orbital. Along y-axis, py orbital. Along z-axis, it will be the pz orbital. But alignment of the electron, exactly we do not know. But overall orientation of the electron we can understand. And that overall understanding the electron is nothing but the orbital. Students could able to understand what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Now about the d orbitals, if I have to talk, then shortly I inform to you. If I consider it is a x-axis and here's a y-axis, then dx square minus y square orbital means the lobes will be along x-axis and y-axis. It's one kind of p orbital. Other p orbital, likewise you can consider. Actually, it's a d orbital only. This flower kind of arrangement you are finding, that's what the d orbital. And the name for that d orbital is dx square minus y square. If I have to draw the dz square orbital, then I have to consider this one as what this, I was considering this as a y-axis. No, I consider it as what the just wait, it is not going. Okay, I obtain again. Let me consider z-axis. Then that z square orbital can represent along z-axis. Along z-axis, and in between x and y there is what as like Saturn, or on Saturn there is a ring, no? Likewise here remains a ring kind of structure is there between x and y axis. So this is a representation of z square orbital. What about xy orbital? The lobes are between x and y. Here, no, lobes will be a different color I show to you. See, lobes will be between x and y. Similar shape, likewise the x square minus y square. But lobes will be between x and y. That is our dxy orbital. Means that blue color which orbital is there, that is our dxy orbital. Similarly, dyz means lobes between y and z. dxz means lobes between x and z. So d orbitals we can divide in two parts. Axial, and these three orbitals are non-axial. Axial means lobes are along axis. So that's the angular distribution of the orbitals. So Namrata, had I answered your question?
Yes, sir.
Okay, did you understood? Means concept clear?
Yes, sir. Thank you, sir.
Yeah. Other students, the question asked by Namrata and answer that I provided regarding the orbital or their angular distribution. Is it clear to all?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, right from historical aspect we went. Great thing. Great. Good. Yes. Any other question? Any doubt?
Sir, how to
Yes,
fill
Faryaz.
attendance? How to fill attendance form? Will you repeat it in shortly, sir?
Yeah. See, for attendance, there is a one link. You get the link, otherwise I'll share that link again. And in that link, then Google form is there. And in that Google form, lecture date, lecture time, lecture topic, you were present for live session, because lecture I don't consider only live. If I provide a recorded lecture of the live lecture, or only recorded lecture, that also is a lecture. So lecture number point that I added. And where will you find lecture numbers? There is a one again, Google sheet is there, and there lecture number, topic of the lecture, date of the lecture, everything is what given there. So that lecture number you have to add. Sometimes in one date I had given 2 lectures. So lecture number is important. So lecture number you will add, lecture date you will mention, and then you will say how were you present. 3 options are there. Present for only live lecture, means this is a live lecture. Second option, present for only recorded lecture, means attended record lecture. And third option, present for both live as well as recorded. Now, for example, now you students are there. You are present for the live session. By the way, when I will upload the recording, you may go through that recording also. So you will be present for both. So I had given that option to you. My at least expectation is you should go through any one lecture. And main expectation, Payas, is assignment completion. I understand your attendance first by assignment completion and then by that form. Payas, is it clear?
Yes, sir.
Yeah. If you do not get the link as such, then you can tell me. Otherwise, inform me now only. Shall I share that link again, or will anybody help to share the link? You also can share that link in your classroom or in the WhatsApp group also you can share. What do you want, Fayaz?
Sir, link shared.
Yeah, you want the link. Yes, will anyone help me? I also can give you, but you should know no links. If anybody knows the link, will anybody post those links voluntarily or nobody's with the link? Yes, Shravani, please help me. So post that link to where? Where? First in classroom announcement remain. No, there you can post. And second in our WhatsApp group, you will post the link for attendance form. By the way, you will post the link for lecture record. Lecture record.
Okay, sir.
Shravani, is it clear?
Yes, sir.
Yes. Other students will get that, and even if Shravani fails, then other students also can help her, and one can post. No problem. And when nobody does, then I will do that. So tomorrow our lecture is there. Meanwhile, I hope that Fayaz will get the links. Fayaz, is it clear?
Yes, sir.
Okay, good. Any other question?
No, sir.
No. Okay, good. At least
No,
reply
sir.
no. Yes, good. Manthan did good thing. Yes, Vaibhavi also did the good thing.
No, sir.
Shepali said no. Yes.
No, sir.
No, sir.
Shravani. Okay, Fayaz replied. Narayan also replied. Sanika sent the message. Yes, students. Tomorrow, I want to give the last lecture for such discussion. So whatever I had taught you through the videos about which we can discuss. So if doubts are there, tomorrow one more day I give for the discussion. Afterwards, we will start the new topic, new aspect, because we have to progress, no? Our study should progress. But too much content bombarded and nowhere progress, I don't want that. Therefore, I had given a fair chance to you to complete the assignment, to ask the questions and to answer your queries. So I hope and expect tomorrow you will be with many interesting questions. Be with all. And by any means, if you find whatever I am answering or I am discussing is not clear to you, you are not understanding, then it is my responsibility. If you are not understanding, then it's my mistake that you are not understanding. But if you are understanding, means you got somewhat hint. I'm not saying 100% understanding, at least. But again, you have to revise that and the concept cannot grow. That consistency should be there from your side. So students, shall we stop now?
Yes, sir.